Okay, movements of the Earth 2.2. We're going on to some awesome things. What we're going to do is describe Earth's revolution rotation. Those are two different things. And a lot of times we use those words interchangeably and they don't mean the same thing. Then we're going to tell why the seasons change, fall, spring, summer, winter. We're going to describe what's going on. And then really we're going to talk about how the sun is really our basis for measuring time. Okay, so the first thing, Earth. A rotation is, pretend there is a rod, the axis of our Earth going straight through North and South Pole, and it's spinning on that rod, right? And as it does, our Earth rotates in 24 hours. Now, close. It's not exact. And so each day, 24 hours and some change is what it rotates. And that is one rotation. Now, what I'd like you to do is watch 1 year from Earth seen from a million miles. Really cool. What I want you to also look for is there's an eclipse that they show. Really cool. So take a moment, hit pause, watch the video, and then I'll see you when you get back. Okay, we're back. So really cool, right? So when we talk about rotation, it's spinning on its axis. A revolution is when the Earth goes around the sun. So it does this in 365.24 days. Now, again, that 2.24 is critical when we talk about our calendar. Our calendars have changed quite a bit over the years to the calendar that we have today. And so when we talk about that, as far as why that 0.24 days is critical, one revolution is around the sun 1 year. Every 4 years, we have a leap year. That's where the 0.24 comes in, right? So it makes sense. How do we fix it? Hey, add a day to the calendar. All right. When we're revolving around the sun, what we're doing is we're not in a complete circle. We're moving almost in an egg shape. It's not egg shaped. It's believe it or not, the distance is not that great off, but when the Earth is closest to the sun, it's perihelion. And we've used these terms before. It's like satellites, right? Perihelion, closest to the sun. That's about 91 million miles in January. I know you're going, wait a minute, January is when we have winter and we're closest to the sun and it's colder. Well, that's from our perspective in the northern hemisphere. In the southern hemisphere, it's summertime. So we'll talk about that in a little bit. Aphelion is when we are the furthest away. Now I remember this like this, away, right? Aphelion is away. And so the furthest point we are, this would be in July. This is 94 million miles, right? Difference of 3 million miles, not that big. I know it is big, but not that big. And this doesn't actually happen exactly in July. It actually happens around the 20th of June. We'll talk about that too. So, seasons. So we mark our seasons by solstice, right? Or a equinox. And we'll talk about that. So the summer solstice, the first day of summer, the direct rays hitting the northern hemisphere, which is the Tropic of Cancer. And if you look right here is the Tropic of Cancer, and we're rotating on the axis, which is right through the middle of the Earth. So right here is the direct rays. So the sun would be over here pointing directly here. Now notice in the southern hemisphere, it doesn't look like it's hitting it very direct at all. That's why it's wintertime in the southern hemisphere during this time. And so while we're further away in the northern hemisphere, we're getting direct light. Now this happens about the 22nd of June, right? So This is when the sun is highest over the Tropic of Cancer. This is where we get our direct rays. Summertime for the Northern Hemisphere. The winter solstice. The winter solstice is just the opposite. So when we are closest to the sun, our rays are striking the Tropic of Capricorn. Now look, the axis of the earth is tilted differently, right? So our sun's rays are coming in, focused down here, and in the winter time for us, we don't get direct rays. So if you're not pointing that flashlight in somebody's eyeballs, it's not as bright. Same thing with the earth. We're not pointing it directly at it. So this happens around December 21st. Again, the sun hasn't moved. The earth is just tilted away. Now, it didn't tilt back and forth. It's just as we're going around, it's keeping its position. And as it's going around, it is still changing where it's the relations of the light is striking it. Okay, so we got summer, we got winter. Well, in between, we have equinoxes. And so autumnal, you can call it fall if you please, but I say I like autumn. Autumnal equinox, that was my little Barney rendition for those of you guys who grew up on Barney. The rays are directly striking the equator at 12 noon around September 22nd. Now, here's the deal. If you look at the autumnal and the vernal equinox, let me see what we got here. Direct rays on the equator, direct rays on the equator. So if you look, hey, the sun is directly over the equator in the autumnal equinox and the vernal equinox. Vernal means spring. And so 12 hours daylight, 12 hours of darkness, 12 hours daylight, 12 hours of darkness. Oh, so now we're just facing from a little bit different direction, but we're both at the same place on the equator. And so September 22nd for the autumnal, March 21st for the vernal. Now, here's what I'd like you to do. I'd like you to pause, watch the summer, what is a solstice, and then watch the equinoxes and solstice from space. Pretty cool, pretty short, but it gives you a really good idea of what we're talking about. I'll give you a couple minutes. When you're done, hit play and we'll get started again. Okay, great, awesome. All right, let's keep moving on. So, precession. Now, I like to talk about this like it's a quarter. Anybody who's ever had a quarter in their hand, eventually you flick it and it starts to spin, and then it starts to wobble a little bit, and then it falls down. Well, our Earth is not going to fall down, right? It's not falling down. But it does have a slight wobble. It's not spinning directly. I've spun basketballs on my finger, and it has that slight wobble. It's not exactly right. And so precession is this wobble of our Earth, like a top, like a basketball on your finger. Now, here's the thing. Because of where we're at, it doesn't wobble like millions of miles an hour. It takes time to go through its wobble. And so right now, our north points directly at our north pole directs at our North Star, Polaris, right? The axis points at that. However, it won't in 13,000 years. In fact, we're about halfway through a wobble right now. What's interesting and how they figured this out, it was really kind of cool. They were trying to figure out what the pyramids lined up to, and they just couldn't figure it out. And pretty soon someone goes, hey, you know, that looks an awful lot like Orion, the constellation, and the belts in Orion. And Egyptians were pretty much known for trying to connect themselves to the heavens and the afterlife, right? So they made that connection to the gods. And sure enough, somebody did a simulation with a computer, ran back in the supercomputer what the stars would look like back then, and bang, there it looks like it lines up with the pyramids, sure enough. And that's how they figured it out. Now, again, we're about halfway through the wobble. It makes it every 26,000 years, a complete cycle. What I'd like you to do is watch how the Earth moves and push pause. Come back when you're done. Okay, you're back. Here we go. So, time zones, right? We always get confused. What time is it? Where is it? What's going on? And originally, time zones were kind of haphazard. They just went wherever. And then people figured out, hey, wait a minute. If we divide our Earth into 24 regions and then figure out how much area it goes, if we do that, then we can set high noon in each region by where noon, the sun is directly over that region in the sky. Now, to be honest with you, it's in the middle. So noon for central time zone starts again at a place, but it's not quite exactly the sun's directly overhead. So off a little bit. So for us being on the eastern side of the central time zone, then that means that it's probably directly overhead a little bit earlier than high noon, but that's in the center. Now, what do we know? We have our Earth, and it is 360 degrees. Divide that by 24, and you get 15 degrees each hour. Now, in the middle here is what we call the international date line. This is not a number you call up and you're like, hey, I'd like to meet some people. This is the area in the middle of the Pacific Ocean where one day starts and one day stops. And you have to have that place, and it's got to be in a place where people are not at. Because if you're like constantly, if you're in Indiana and one day it starts there and the next day starts in Illinois, it gets really confusing. So they put it in the middle of the ocean. And so it runs north to south. On the west side of the line, west side, that would be over here where it says Tonga, it would be, let's say, 8 a.m. Friday. On the east side of the line, it would be 8 a.m. Thursday. And so you have 2 days going. And what I'd like you to do is I'd like you to stop here and watch Understanding Time Zones. I'll give you a couple minutes. Okay, you're back. So daylight savings time. This came about, it was proposed by Benjamin Franklin, actually, back in the day, but it wasn't put into action until World War I. And the reason why they did this is they said, hey, we need more daylight hours to increase our production of people in the field and in the factories. And so they put this daylight savings time in. And all of you in wintertime, you get it. It gets dark earlier. And in the summertime, it seems like the light doesn't go down until about 10 o'clock, 9 o'clock. I was in Sweden not long ago during the summer, and the sun never went down until about 1:30 in the morning. It was really kind of weird. Well, we were so high up there that it stayed light for quite a long time. Pretty cool. Didn't get a lot of sleep, but pretty cool. So there's actually a lot of legislation right now out there to try and get rid of daylight savings time because people are so confused. Makes sense, and with the way things are, people work all sorts of hours now. So it's not like that's really hindering things. Again, spring forward, fall back. That's how I remember it. October, right? Spring forward, fall back. You set your clocks back in October, in the spring, which is in April, right forward. All right. So great job. We're going to take a pause there. I want to say thank you. You guys are so awesome. I just appreciate everything. And we'll catch up with you on the next one.